Hi students, I hope you are fine and healthy at your home. Now we are going to start chapter number 6, second part, where we will see what is work energy theorem. This is very important theorem. Work energy theorem states that the work done by force is equal to change in kinetic energy of body. Work done, the statement of work energy theorem is work done by the force is equal to change in kinetic energy. If we are doing work by any body, then kinetic energy will be changed. So this is the statement of work energy theorem. And now we will prove this theorem. So let's F force is applied on a body of mass m. Suppose that we are applying F force, capital F force, and mass of the body is small m. Then we know that by the definition of work equal to force into displacement. Also by the Newton's law we know that F equal to ma. Okay, so we will put in place of F ma, W equal to what will we get? Mad. This is very simple things we have done. We know that work equal to force into displacement, and force is equal to mass into acceleration, and we will put in place of F ma, then we'll get W equal to Mad. This will be our equation number first. Now for the equation of motion, we know that if body is displaced, then work done is V square is equal to U square plus 2as, or we can write as a V square minus U square plus 2as. Here s we will replace by d, so we will write here small d. So 2ad equal to V square minus U square, or we'll do cross multiplication, ad equal to 1 upon 2 V square minus U square. Now this equation, suppose that is our second equation. Putting the equation second in equation first, ad in place of ad we will write 1 upon 2 V square minus A square. What will we get? W equal to MAD was there. W equal to M half V square minus U square. Or we can just write W equal to half MV square. We are opening the bracket and just writing that minus half MU square. That means the work is done by the body is change in kinetic energy. First kinetic energy will be mv square, then after it will be the mu square. That means work done by the body is equal to change in kinetic energy. This is our work energy theorem. Try to solve again. Now we'll see another derivation regarding to the this work energy and power. This is also important. Expression for kinetic energy. Question will come like that. What do you understand by kinetic energy? Drive by expression for kinetic energy. So we know that we have studied in 11th class, 10th class that the efficiency of work done by the motion of body is called kinetic energy. Efficiency of work done, it is energy, but with the motion it will be kinetic energy. So suppose that we have a body which have a mass small m at rest position, and the force applied by the body is capital F, and A is the acceleration produced by the body, and V is the velocity acquired by the moving distance with s. Suppose that we have this kind of factor. By the equation of third equation, we know that V square minus E square equal to 2as. This we know that. Question number first. But here this is a initial velocity. V, capital V is a final velocity, because body was at rest, so no initial velocity was there. So u small u equal to 0. Then we will put u equal to 0. Then we will get V square minus 0 equal to 2as, or we will do cross multiply, cap a equal to V square upon 2s. By this we get. We know that force equal to mass into acceleration. Here we will put the value of A, mass, V square upon 2s. Also we know that work, by the definition of work, W equal to force into displacement. Force we have determined this Displacement is s, mv square upon 2s multiplied by s. So s to s will cancel, then we will get w upon mv square upon 2, that is our kinetic energy, k equal to half mv square. That means the efficiency of done by motion is called kinetic energy. Thank you. Try to solve this kind of questions by yourself.